Today we would like to talk about a series of water rocket and our experiments.
What is water rocket? It's basically an upside-down physics drinking water. Unlike others, water rocket use water's force to push the rocket up to the air. What makes a water rocket fly? First, the compressed air pushes on the water as it tries to expand. Second, the water pushes downwards through the nozzle. Third, the water rushes through the nozzle, making the thrust to counter the weight and air resistance. Fourth, the thrust pushes the rocket upward into the sky.
Conservation of momentum. It means the total momentum before and after an event remains the same. When the air is pumped into the bottle, it gives the water rocket enough thrust to move upward. And according to Newton's second law of motion, when water is ejected at high speed, it provides an upward thrust. As the rocket's mass decreases, its acceleration increases, making the rocket fly faster and higher.
Newton's third law of motion, action and reaction. When one object exerts a force on another object, the second object exerts an equal force in the opposite direction. Application of Newton's third law in a water rocket. The expelled water exerts a reaction force on the rocket body, propelling it forward and allowing it to fly.
The next is projectile motion. It refers to the phenomenon where an object is launched with an initial velocity from the ground or a certain height at a non-vertical angle, and due to the effect of gravity follows a parabolic trajectory in motion. Aerodynamics. Aerodynamics consists of lift, resistance, drag, gravity, and thrust. First come from lift. Lift is an upward force that is perpendicular to the direction of fluid flow. It opposes gravity and helps objects stay in the air. The generation of lift is relative to fluid dynamics and is commonly observed in the motion of airplanes, helicopters, kites, and other flying objects.
Drag is a force that opposes an object motion through a fluid, especially air or water. In a life, we can see it will apply in airplane, cars, apertures. Next, I would like to talk about resistance. The definition of resistance is any force that resists motion. The direction of resistance is always opposed to the direction of object movement. When the resistance equals thrust, the object will move at a constant velocity in the fluid. The application of resistance in a water rocket is when a water rocket just starts launching. And when the water rockets fly in the sky, it will have resistance. And I would like to talk about what different from the resistance and drags. The drag is included in resistance. So if object have the resistance, it will have a drag in the same time.
Gravity is the force that pulls object downward. In a water rocket, gravity pulls it back down after launch. Opposite thrust. The rocket height depends on balance between thrust and gravity. When thrust decreases, gravity takes over, bringing back to the ground. Thrust is the force that moves water rockets forward, created by experiments in the opposite direction from Newton's third law of motion. In a water rocket, thrust is generated when high-pressure air forces one out of the nozzle. The repeat expulsion of water pushes the rocket upward, The more pressure and water used, the greater the stress, making the rocket fly higher. How do we design the experiment? First, we use temperature as independent variables. Second, we find that temperature is too hard to control. Third, we use pressure as independent and we fill 400 ml water into a bottle. Then 400 ml water is too heavy for water rocket. Finally, we added 150 ml water into a water rocket.
Next, I want to talk about dependent variable. Our dependent variable is water rocket flight distance. We use phone range finder to measure the distance. It can make sure our figure more correctly.
Our controlled variable are the place in Zhudong Senior High School, the angle 45 degree device, water volume, empty bottles weight, fins in four, launch direction, nose cone, transmitter, temperature of the water and pump. And our dependent variable is pressure.
First, we assumed the higher water temperature, the fuller distance, but use temperature as independent variable is too hard to control. Then we assumed the higher pressure, the fuller distance.
In this experiment, we learned two things. First, finding assist for help is very important. At first, we insisted on trying ourselves and didn't discuss our experiment with our physics teacher, so we faced several failures. For example, our flight distance is short by about 4 meters, but after we find our teacher and discuss our problem, our flight distance increases to 89 meters. Second, teamwork will influence the team efficiency. If we don't have nice teamwork, we won't complete our experiment. In our team, we cover each other to keep the team working. At long last, looking back to when we first heard about this experiment, we were filled with excitement. We spent nearly half of our winter break meeting up to work on our report and conduct experiments. Some of us had to wake up at 6 to catch the train, while others had to attend tutoring classes late into the night after a full day of experiments. We poured so much time and effort into this, all for the sake of this unique experience. Each time we conducted the experiment, we spent hours adjusting the launcher, only for our water rocket to fail in the end. Then, as the new semester began, our entire class gathered on the playground to launch the water rockets. Some teachers were even startled by the sight and reported it. During the holiday following the start of the semester, we continued meeting up to complete our experiments. However, it was at that moment that we realized a fundamental issue in our experiment. Unfortunately, it was already our last chance to test it. A sense of discouragement filled the air. We lacked the knowledge to solve the problem. In the end, we turned to our physics teacher for help. We conducted repeat experiments, analyzing the issue over and over again. Eventually, we identified the cause of the problem and adjusted our variables. We changed our variable to air pressure variations, and with our teacher's guidance, each launch became more successful than the last. Our emotions shifted from disappointment to excitement. Through the experiment, we discovered that the higher the air pressure, the farther the rocket traveled, and it launched steadily each time. This realization gave us tremendous confidence. This was an unforgettable experience. Though we faced setbacks and moments of doubt, it was through failure that we ultimately achieved success. These experiences have become invaluable lessons that will nourish us throughout our lives, whether as a cherished memory of our youth or as knowledge that will leave a lasting impression on our academic journey. This experiment has left a profound mark on us.